Hi guys, my name is Ludo and I'm super excited to join you today at this event. And yeah, we will be talking about deployments and operations. So for the context, name is Ludo. I joined the Txtx ecosystem 5 years ago. During my first 3 years, I was focused on the blockchain, the Txtx blockchain, mostly focusing on the Clarity VM. And then after the launch of the blockchain in January 2021, I started focusing on developer tooling, so making sure that developers have all the tools they need when it comes to write smart contracts using Clarity. I also Clarity, Clarinet, Chainhook, and a few other tools. And I've also been quite involved on some other on-chain projects like porting the stacks, the PIF network to stacks along with Wormhole and while working on those projects, I've been facing a few issues that I like to see fixed. So yeah, that's Txtx. To give some more context, let's start with like the typical Web3 developer journey. So when you start working on a protocol on Stacks or any blockchain really, you have 4 big steps. Develop, debug, deploy, operate. So develop, you write your smart contract. So if you build on Stacks, it's going to be a mix of Clarity contracts. Maybe you have some Bitcoin scripts here and there, but mostly Clarity code. Then you have the debug phase. And by debugging, I mean writing tests, unit tests, integration tests, doing some first testing, involving auditors as well, whatever work for catching those bugs before deployment. And then we have deploy and operate. So by deploy, I mean the action of moving those source files living on your laptop to a unstoppable decentralized blockchain. And operation, I mean, like from time to time, you have to operate on your contract. So for instance, if you run a DeFi protocol, you may have to tweak certain parameters, you may have to run some DAO decisions. Sometimes you also have to upgrade your contract. So it's most of the case a pretty scary moment for developers because you end up manipulating private keys and things are it's like one-off operations often, and it's the goal with Txtx is to help builders being prepared for the unprepared. And so when you compare Web 2 and Web 3 on the maturity of those operations and deployment, there is a huge gap. So on Web 2, and if you consider the cloud infrastructure space, we were able to reach a level of maturity thanks to tools like Terraform or Kubernetes, making things reproducible and great. On crypto, we are far from here. The standard is to write JavaScript files and Bash scripts. It's quite scary when we consider the fact that blockchains and Web3 are supposed to be the digital money infrastructure. So with Txtx, the goal is to fill this void. And so to do that, we are introducing a new primitive. It's the concept of smart contract runbooks. So a runbook is a workflow or a recipe of actions that developers want to take on chain. We're not asking developers to do more work. In fact, when you compare, left with right, we are performing the same thing, except that on the left, we are writing a JavaScript file. We are describing how to do things. And we can do the same thing using some declarative code and a good runtime. And yeah, with Runbooks, you really focus on what needs to be done instead of how things should be done. And yeah, thanks to that, you can really prepare your protocol and your operations for critical moments. If we zoom in on the anatomy of a runbook, so as you can see, the language is declarative, meaning it's really easy to generate. And we also have some important properties that I'd like to mention. So first, composability. So a runbook should be able to call another runbook. With Web3, we have this notion of modularity, composability, where we want to have protocols being able to interact with other protocols. And like as of today, it's really hard to, we can do composition on chain, but being able to reproduce this composition off chain in a sort of clean white room is very complex, almost impossible, because like you need to redeploy some protocols that you're not necessarily familiar with. You have to initialize them. So composability is broken today without good tooling. Then we have the idea of explainability. So we want documentation to be a first-class citizen. So we are really pushing for documentation. And finally, we have extensibility. So this issue that we are observing is not unique to Stacks or Bitcoin. It's widespread on Web3. So it's also EVM, Solana, and others. So we created something very modular where you can mix multi-chain actions in your runbooks. Okay, so we have the runbooks. What's next? So the next step is execution. You can execute those runbooks in your terminal like you would do with a JavaScript file or a bash script. Nothing new here. I think the big evolution that we came up with is you can run those runbooks in your web browser as well. And when you do so, you have access to a runtime that allows you to interact with your web wallet. So the runtime is prompting the developer for signatures that can come from a web wallet. And so with that, we are fixing another key issue that we want to get rid of. It's related to security. So as of today, when you operate on your contracts or when you deploy your contracts, you end up manipulating your private keys by copy-pasting those private keys in your script, which means that your private key is not living in a secure enclave. It's probably living on a notebook or notes or whatever. And so it's a big issue. Like every year, between 500 million and $1 billion are being lost because of compromised private keys. And so, with this system, the private keys are staying where they belong, meaning in a web wallet or in a ledger, which is also fixing a key issue. Finally, one important thing. So we are Web3 developers ourselves, and so we understand the core values. All the tooling is designed to run on a laptop. The laptop can be offline. There's no cloud lock-in here. So yeah, the system is also fully decentralized. And yeah, with that we can do a quick demo. So the demo will be focused on some very simple Txtx contract. Okay, so we have this project with let's say 4 contracts. So contract A. So in this contract A, I have 3 functions: function A, B, C, all returning true. Then I have contract B. So I have function A, B, C. A calls contract A function A. Function B calls contract A function B. Function C calls contract A function C. I also have contract C with function A calling contract B, function B calling contract B, and so forth. So here the idea is to highlight a typical case where in your project you have a few contracts depending on each other. And finally, we have contract D, contract calling contract A, B, and C. So to sum up, we have A is called by B, B is called by C, and D calls A, B, C. Okay, so let's look at a first runbook. So as you can see, this is the declarative code that I was mentioning earlier. So if you're familiar with Terraform, we essentially reused the same language. We've been tweaking the constructs to make them feel more like Web3 native. So we have the concept of add-on, of signers, we have actions. But yeah, if you can write JSON, then you can write runbooks. There is like a domain-specific learning curve, but there's no like learning curve related to the language itself. And yeah, so we can dive into the details. So here I'm instantiating a Txtx driver because my runbook is manipulating some Txtx constructs. I have a signer named operator v1. I am at this point hardcoding a mnemonic. And then I have a few actions here. So by declaring the add-on Txtx, I have access to a bunch of constructs. So the one we will be using today is deploy contract. So this first action named deploy contract A will be executing the deploy contract action from the Txtx add-on. We have some description. So here we are specifying the fact that we will be loading the contract A coming from the Clarinet project. So essentially referring to this contract. Then this contract deployment will be handled by the operator v1 signer. And finally, we want to assign a name at deployment time. And so we will be calling this contract AV1. We are doing the same thing with contract B, loading contract B. Same goes for contract C, contract CV1, same signer. Then contract D again, contract DV1. And so here we are simply deploying another contract, which is also contract D, but that we can name differently. I need to delete that. Okay, so going to my terminal. So I have Txtx install my machine. I can do Txtx ls. It's going to display the different runbooks installed. The different runbooks available in this repository. Here I have a manifest file indexing the different runbooks. So we are looking at this guy for the moment. We can also specify some general inputs. Okay, so in this case, I'm going to execute the deploy ABCDE runbook. I will be deploying to DevNet. I am running a DevNet network here, thanks to Clarinet. And for now, I'll be executing this runbook in unsupervised mode. Okay, so here I can see that in my mempool, I have contract V1 being deployed. Next block, Txtx is sending contract B. A new block is being mined. Contract C is sent to the mempool and then being mined here. And finally, we have contract E and contract D being sent to the mempool. Gorgeous. So we were able to deploy a few contracts quite easily. So all the dependency graph is automatically being computed under the hood. And so here, the nice thing is that so Txtx is also doing something around the hood. It's tracking the state of the execution, meaning if I update my contract, like I will need to redeploy everything, right? So in this case, I did modify contract A, meaning here I want also to, so updating contract A means that I need to deploy a V2 contract. And so if I have a contract A V2, then I also need to update contract B because contract A is hard-coded. And same goes for contract C. And so when you work with this kind of issues at scale, so if you look, for instance, at some protocols like Alex or Arcadico or Stacking DAO, like they have like between 50 contracts and 100 contracts. And tracking those dependencies are quite challenging. And so we're doing this under the hood for the developers. So for instance, here I did update the contract. Okay, so first, maybe not edit it. So if I try to redeploy the same runbook, the contracts haven't changed, there's nothing to do. But now if I update one of the contracts and try to redeploy again, so we were able to detect some changes in one of the contracts, and we are also able to detect the fact that there will be a cascade of contract deployment that needs to occur. And yeah, so we are able to automate this thing for the developers. All right, so another execution mode that I would like to demo is this idea of supervised mode. So here, as you saw, we ended up hard coding a private key in the runbook, which is a pattern that we want to get rid of, as we explained earlier. And so, yeah, I'm going to start with this one. So I have another runbook here. It's much simpler. So I have a signer. Instead of using a secret key signer, I'm going to use a web wallet signer. and I can specify the address that I want to see signing my operations. And then here we're going to have one action, so call contract. Earlier we had a deploy contract. This time we're going to be calling contract. So I can pass the contract ID, the name of the function, arguments, and here I will be using operator v1 first. So if I run this, Txtx allows, I'm going to do Txtx run net. So this time I did not pass the unsupervised flag, so by default we will be using this mode. And so if I open this URL, I have access to what we call the supervised mode, like all the supervisor UI. And so it's a UI that we designed for assisting developers when running their operations. So in this case, it's just a simple contract code that we could be deploying contracts or, yeah, pretty much anything. So, and it's really like a sequence of checks. And the goal here is to make sure that developers are doing the right things. So step one, connect the wallet. So that's something that I did earlier. Then check the signer balance to make sure that we won't be running our fund during the runbook execution. So I can start the runbook, check the nonce, check the fees are not too high, and this is the transaction payload. And so here, instead of copy pasting a private key or running my ops, Txtx is prompting for a signature. And so, yeah, with that, I can leave my private key in the web wallet. Transaction is sent to the blockchain. I can see that my contract code is here in the main pool. So if I mine a block, confetti, the transaction went through. Okay, so that's a first step. What if we want to go further? And, with blockchain, we have something really cool. It's the concept of multi-signing things. And with Txtx, we want to promote those practices that we consider being best practices. And so here I want to upgrade this single signer process. So I'm going to declare one signer for Alice using the web wallet, same construct that we had earlier. Another signer called Bob, same web wallet. And then we have this third signer that we are calling operator v2. And this time it's a Txtx multisig. And we are specifying Alice and Bob as signers. So the only thing I need to do here is to update the signer and point to the operator v2. And so if I try to re-execute this runbook, so things are slightly different this time. So check Bob expected address. Okay. So I'm going to press this toggle. And so with that, my local Txtx is going to create a remote endpoint that I can share with my teams. And so in this case, I have this txtx.link that I can share on Slack or Telegram or whatever. So let's say Bob is living on another machine, he can open this link. It's gated by a OTP, so it's 473 line 31. And so now we have Alice and Bob looking at the exact same workflows and being able to interact and synchronize on what needs to be done for those operations. So first step is to have everyone connecting their wallet. So Bob needs to connect. Thanks. So on the left we have Alice, on the right we have Bob. So Alice starts the runbook. Alice is checking the nonce, the fees, and now we're gonna do the multi-sig ceremony. So the first signature is coming from Alice. So Alice is signing with her wallet. Cool. Now we have Bob. Bob needs to sign with his wallet. Perfect. And then Alice validate the transaction. And so, yeah, in this case, we had Alice and Bob going through a multi-sig ceremony, producing a transaction that is being broadcasted to my local network, which is quite interesting. So if we mind the block, confetti, yeah, we had this cool multi-sig being, yeah, line function C. Okay, so function C was called by this SN address. SN indicates that it's a multi-sig address, testnet. So yeah, really easily we saw that we were able to help Alice and Bob migrating to a multi-scheme ceremony. So, and yeah, maybe something that wasn't clear as well. So those runbooks, with all those constructs in the runbook, we are producing a direct acyclic graph of actions. And so by introducing this notion of statefulness, then we are able to paint some nodes in this execution graph. And so let's say that my protocol is composed of 3 contracts, and so the last contract also needs to be initialized somehow by some subsequent contract calls. Painting the contract upgrade will also automatically paint the dependencies. And so with that, you have the assurance that your deployments will always be correctly performed. And so it's not, it can lead to, not doing that can lead to big issues. Like for instance, I think the biggest hack I saw on Web3 was the wormhole protocol being hacked, which was hacked exactly because of those reasons. Like a contract upgrade was incomplete. The subsequent initializing functions were not correctly called, and so yeah, ended up in a pretty messy situation. So yeah, we can do a bunch of stuff with those runbooks, like operations, deployments, multi-sig, CI/CD, and yeah, so the current stacks add-on is currently on RC1. You can use it. Documentation is available on docs.txt. I can set the stage. And yeah, feel free to shoot some questions and feedbacks. Thank you, guys.